Hello, welcome back, and today I will discuss about how to set up two NoSQL databases. So the first one is about Cassandra and the second one is ScyllaDB. So what I will be covering is the first one. I will talk about the installation of those two databases, and second one is the configuration, and third one is the backup and the restore process of the database. And also lastly, I will try to test the read-write speed of both databases using Cassandra Stress, the integrated and built-in tool in when we install those two databases. So let's talk about the Cassandra installation first. Before we can install Cassandra, we need two servers for this test case. So I will be creating two droplets. And for version, I will be using Ubuntu 22.04, and I will use the CPU and memory optimized. So let's just try to use this one. 8GB RAM and 4 CPUs. Alright, and yeah, let's create those droplets. So the first thing that you should do is to run an update, apt update, when you connected to the droplets. And once you finish updating, you need to install Java OpenSDK 11 for compatible with this Cassandra. And after OpenJDK is installed, you need to import the Cassandra from Debian, and I have included this setup in the description below. You can check it out. And also you need to download once you import the Debian. And once you finish download it, and you need to also run another update. Once the update is complete, you need to download the Cassandra now. So let's run apt install Cassandra. Oh, now Cassandra has been finished installed. We can proceed to the configuration step. So now I have cleared up the history command. So after you install Cassandra, you can check its version running Cassandra-v. So it says 4.1.4, and it means Cassandra is already up running. So we can configure it now. So what you need to do is, after install the Cassandra, it will automatically run its own service. You can check it by systemctl status Cassandra service, and it says it's already running. So when it runs, it automatically saves its test cluster as its default name. So in order, we need to change the cluster. We need to stop it first and update the cluster name in the CQLSH, and we can change it to whatever we want. So right now, let's go into CQLSH. This is the first thing. So it says connected to the test cluster, and we don't want to use that test cluster name. So you need to update the system local. So for example, I will be changing the cluster name to something else. So let's say I wanted to put Cambodian. So update system local set cluster name for Cambodia where key equal local, so we hit that and then we exit. So don't forget to do this for both of the nodes. So let me just do it on another node as well. So coming here, CQLSH and paste the update and exit. So once you exit it, you need to flush the system. So what it means is that when you run the node tool flush system, it means it writes from the mem table into your system. So I will just flush it. So the data that are stored in memory will be stored into the hard drive in this server, so it will not be in the mem table anymore. So after we flush, and we can hit clean up as well. So I flush the system, I run node 2 clean up. So once you clean it up, you can remove the cache in this directory. Okay, so now this is done, you can actually edit the config. So let me show you its default config first. So the default config is in the etc Cassandra and Cassandra YAML. So in here you can see that the cluster name is test cluster. So that is the default one and we need to change that. And there's a lot of configuration in here and I will not able to show you all those. But I have prepared my own configuration that specifically for this video. So here let's check. Let me zoom in a bit. So in this configuration, what we need to do is to specify the cluster name that we want, and for listen address is the private IPv4 of this node. If you want it to connect to the other node as well in a cluster. So the cluster name I will set it to Cambodia, and for listen address I need to get the private IP from here. And if it's only have one data center, you can put the private IP, but if it's not in the same data center, you can join it in the cluster, but you have to put public IPv4 in the listen address. So after you set the listen address, you need to set a RPC address to 0.0.0.0, meaning it's available for all client access. But if you want it for a secured one, you need to set it to some other IP that you only allowed from. So in this case I will be testing for all, and once you make it for all, you need to set its broadcast address to the public IPv4 of this node. So let's just copy here for cluster 1, node 1. Alright, so once you set all these, the next important thing is the seed provider. The seed provider is important for the other nodes to join the cluster. So the seed is the private IP or the public IP of the node itself. So if you only have 2 nodes, you can just put the 2 nodes so that once it open up and running the service, it will use this seed as the reference to find each other. So let me put the private IP since I put it in the same VPC, and the other private IP I believe is it's 03. So yeah, but it's if you have a lot of nodes, you don't have to put all nodes in this. You can just leave it like 3 or 4, or 2 to 3 is fine. So enough for the seed provider. And the endpoint snitch means that I'm using the simple snitch for one data center. So right now I'm just testing with one data center, so I will be leaving as the simple snitch. But if you have another data center, you can actually change it to other snitches as well. Please refer to the documentation for more information. And these are the default. I don't want to change it. And here in the authenticator, right now I don't put any password for my cluster or the CQL, so let's leave it like it is. But if you want to put the password, you must change this to password authentication and something else. So let me copy this config. But before we copy, I will remove the default config first, and I will nano this one. Okay, I will do it one for this first, and I will do another one for the second node. So once you have changed the configuration, you need to run a demo reload, and also clear the cluster name again if it has any problem. Do this just now, and I run the demo reload, and I stop the service and start it again. So let me just stop and start. It should take a while, and now it's already loaded. So let's check its status first. It's active running. Okay, it's good, it's active running. So to make sure that the cluster works perfectly, we need to repair it first, since we already make some changes to the cluster name. So run node to repair. Okay, it says repair successfully. I think let's one thing that you can just repair one, because it's already having the same cluster name. So let's check its status. Alright, so when you hit node 2 status, it will show there are actually 2 nodes are online. But if you only have one node in the cluster, you need to put it will only show one. So, but it's not effective if you just put one node in the cluster. So but in this test case, we're gonna use 2 nodes. So now the configuration is complete. We will try to test on creating Keyspace, which is a database, also inserting some information. So let's clear this up first. So in this case, enables Cassandra security. We're not going through that one, but if you want to add a password or security on top of it, you can refer to my notes. And now let's create a Keyspace in enter the data. So we run into the SQL/sh, and right now you can see it says connected to Cambodia for this local. So right now you can see I'm running on Cassandra node 2, but it is the same thing. If you run it on here, it will just be the same thing. So since it's a cluster, but let's just create Keyspace. So this is the NoSQL command. So create Keyspace. I call it Cambodia. It's like a database name, and with replication, simple strategy, and replication factor for 2. So the replication factor meaning that it make a copy of the data. One data make a copy of itself by 2. So meaning that its data chunk are stored in 2 different nodes. But if you have 3 nodes, you can still keep as 2, but for more availability and fault tolerance, it's recommended to put 3. So which means one data chunk are replicated 3 times and put in the same 3 different nodes. Okay, so I will just go for 2 right now since I only have 2 nodes. So I created this Keyspace, so I can create the table in that Keyspace as well. So I create 2 tables here called currency and province. So I already create 2 of this. So what you need to do is to insert the data. So we need to use the Keyspace first. So use Cambodia, and it's now Cambodia, and right now it's just run a NoSQL insert into. So I will be inserting 2 data, and I'll be inserting another 2 data into the province table. So the first one is currency. Okay, now I finished inserting. I need to display it. So it's just running a simple MySQL or Postgres commands. So this is from currency, it shows. And I run it from node 2, right? So if I check on node 1, so CQLSH, and paste in. Oh, I forgot to use the Keyspace. And see, the Keyspace is already there, and let's select, and it will show the same thing. So it means the cluster, each node are in the cluster. So once you query or input, you are inserting into the cluster and query from the cluster itself. Okay, so this is the how to insert and display the data, and the next part is we gonna try to delete the data and restore it back. So let's move on. So let's talk about how to backup and restore the data. So the data of Cassandra are stored in a binary format, which is SSL table, sorted string table. So the flow of the data is the data is inserted into the mem table, and then it goes through commit log, and once it's reached commit log, it will be transferred into the hard disk. So it only when initially if you insert less amount of data, it will not go into the hard disk, it will just stay in the mem table. But if it's reached a certain point, it will automatically write into the hard disk. But you can also force this operation by using the node tool flash as earlier. So this is how the data work. And now let's try to make a snapshot. So to make snapshot, you need to exit from the CQLSH first, and this is important. So the first thing, so since the data we insert earlier are stored in mem table, we need to flush it first. So we run node tool flush, and it will flush the data into the hard disk. So this is concerning that when you flush it only write into the specific node. So since all data are stored across different nodes, so you need to flush them both. So we need to flush on node 1 and also on node 2. Node 2 flush. So once you flush, the data will be written into the hard disk, and now you can create the snapshot. And let's create the snapshot first. So here if we run the node tool snapshot, and this is my test Keyspace earlier, I can change it to Cambodia. When you run this command, it will automatically create a snapshot with the snapshot name is a timestamp. But if you want a custom snapshot, you can try to use node tool, snapshot-t, and the name of the custom snapshot and the snapshot name. So right now I will use the custom name. So let's say I will be using ABC. I copy the command here and insert. So it's already created the snapshot directory ABC, and also for node 2. No, copy wrong. Okay, so this one are created, and now let's check the path of the snapshot. So this is the snapshot path, and you need to I need to change the keyspace name. So let's just cd into the data first to show you. Cd more data. So let me list down. So in the data there are all key spaces, default key spaces, the system and stuff, but I just created another one which is Cambodia. So let's cd into the Cambodia key space and list it down. So so in this key space it will store all the tables indifferently. So let's cd into currency and list. Okay, so what happened? So here you can see in the, let me clear this one. So you can see in this table, currency table, there are backups, there are these type of SS table files, and the snapshot. So initially if you haven't snapshot, you will not see the snapshot folder, and these are the data of this currency table. So you need to, so once you want to restore, so this is a backup process, it's already done, and it's the same for the other table as well, which is province. It's the same thing, and on node 2 it's have the same structure but different data. So now let's talk about how you restore the data. So let's try to, so we already make the snapshot of the data. We need to delete the data in our cluster first in order to make sure the data has restored. So use a Cambodia key space, and let's say I truncate the table, which means I delete all the data from the table. So right now I delete from currency, I delete from province. So initially there are like 2 pieces of data in there. So now I already deleted all. Let's try to select from, and now there are no data in currency, and let's from province as well, there are no data. So the same thing from here, CQLSH, use Cambodia, select R from currency. Okay, there's none, and also province as well. There's none. Okay, good. So now let's exit, and let's exit and clear this command history. All right. So to restore this, you need to make sure all is this is an offline operation, but for online operation you can use the SS table loader, but I will not be cover this in this video. I will just use the manual operation, which is the offline one. We need to copy and paste the data from snapshot folder into the default table folder. So what you need to do is to stop the Cassandra service first. Make sure you stop it on both nodes. And you cd into the keyspace. So I already cd'd in here. So let's just back into the keyspace name, and you need to cd into the table. So let's say I want to restore the data for currency. So if you want to restore all the table, if you have a lot of table, that will be a massive problem since you need to copy all the data. But there is an online third-party tool that can speed up the process. And this is the limitation of how you can restore your data. So let's say I want to restore the data from the currency table, and there's no data right now because all the data is deleted, so it's also deleted as well. But let's show you in the list in the snapshot folder. So in snapshot folder, they also like the ABC snapshot, and it's truncated whatsoever another one. So what you need to do is let me list the snapshot and ABC for you. So there is like the SS table data format, the files in there, and what you need to do is to copy this file into the table, the actual right now in the currency table. So which means that earlier you can see the data are there and it's gone when I delete it. So when you copy this data back into the folder, it will show back the data, but you need to copy for all the nodes. So let me just run the cp snapshot, which means copy from the snapshot folder ABC and all files in there to this directory where I'm standing at. So right now, once copy is done, I can list down. So there you go, and it will show you the data. But the manifest.json is not important. You can just remove the manifest and it's done. So right now I already finished copying for one table, which is currency, and I have to, if you want to restore all the table, you can just restore all the table in this first node and then move on to another node. But let's say I don't want to restore the data from province, so I will just do this for the currency, and in here I will do it for the currency as well. So let me go into this directory and go into the currency. Okay, so cool. So I can copy all the data to this directory. Snapshot, cp snapshots, no such file or directory. Okay, so let me, why did I write ABC one? Okay, never mind. Okay, so let's change it to back ABC. Okay, now it's done, and you can list it down, and there you go, there are files in there. So remove manifest. Okay, done. So now you already copied the SS table files, and you can just start the Cassandra node right away. So let me clear all these things, and let me just start the Cassandra. Okay, start the Cassandra on one node as well. Okay, so once you start, you will have to wait a little while for it to work, and you can just check if it's running. You can just use the node tool status. Oh, it runs pretty fast as well. But after you like restore, copy and paste the file, you have to repair it as well to make sure all the cluster is worked perfectly. So let me run node tool repair. You can just run it from one cluster, and now once repair is done, you can check the status. Okay, the status is up, running good. So let me clear all these things, and now let's go into the CQLSH. And now, so earlier I only restored from the table currency but not the province. So let me check the Keyspace. So check the province table first. So select all from province, and there will be no data at all. But if I select all from currency, boom, the data is back. See? So this is how we restore the backup and restore the data. So let's try to check it on the node tool as well. Use Cambodia, select all from province, so there will be none. Okay, and if I select from currency, it will show the same. So now let's try to insert into the table of currency. Let's insert something. I think it's there. No. Okay, insert into currency. Let's say call this baht, Thai baht. Okay, so let's list. Okay, it's working good, and if I insert there, it also show it here. So yeah, this is how to backup and restore. And let's move on to another part, which is read and write test. So for read and write test, we gonna create another droplet just for that. So we can actually run the Cassandra stress from the node, but it will impact the performance of that node. So I don't want to do that. So I will create another node just to use the Cassandra tool in order to stress test the nodes. So in this case, I will create the same one in this the same VPC as Cassandra, and I will also use the same version of Ubuntu, and this one I will still use the CPU optimized $84 per month. And yeah, let's create it. So now I have connected to the Cassandra stress, and what I have done was installing Cassandra like we install for the node, and this should give access to the Cassandra stress tool. Here, there you go. So now we want to test the nodes, the performance, the write and read speed. So what we have to do is to run the stress command. So here I prepare the stress for the cluster. So this Cassandra stress is to stress the cluster. So for example, now I run Cassandra stress write, and it's the number of operation, which is 1 million, and the rate I put the thread equal 4 because my droplet that I created earlier was this 4 GPU. So here currently using 8 GB of RAM and 4 vCPU, virtual CPUs. So which means it has 8 threads. So we will be not 8 threads but 4 threads, but so we will be using 4 for our threads. And this node is just for the cluster. So which means that we can also put just one node, but this is act like the seed. So now let's just try to write a million record. So and compare how much will it operate, and yeah, let's maximize this for better view. So let's I zoom out a little bit, and then I paste the command. So it will try to create a default key space, which is Keyspace 1, and also its own table as well, and insert the data. So let's run it now. So we will just wait for a while after it finish operating. So it will try to create a cluster if the cluster haven't created yet, and it will try to insert 1 million records of it. So I will let it leave it right now, and it will display all the data. So now it's already finished trying to stress test, and as the result it said operate rate, which is 10,000 operation per second, and yeah, it's the same as partition and row. So which means if we have the 4 GB of RAM, 8 GB of RAM and 4 virtual CPU, it will, when it insert 1 million records, it will insert like 10,000 per second, around 10,000 per second. And it's really not very accurate, because like in the reality when production we have a network firewall and other stuff, but this is just for testing. So it means that it's for write 1 million records, and it will write 10,000 per second when we have the 8 GB of RAM and 4 virtual CPU, which is 4 thread as well. So it increase if the thread increase as well. So this is the scenario, we just put the threads equal 4, but you can test other thread as well if you have more threads, but we only test with 4, and the 4 is like, it's already costing $84 per month for the droplet. Let's just test the read. So we will use this 1 million and thread equal 4 to as a baseline for our comparison. And yeah, let's run the test with read rate. So we have finished the read. So we can see that the operating rate of the read only like less than 10,000, which is only 9,000 and a half read per second. So yeah, with that certain amount of CPU and RAM specification, it reads a little bit slower than it writes. So yeah, this is Cassandra, so it write it's prioritized write more than read. So yep, so if writing a 1 million reading 1 million record, it only like takes up a minute and 44 seconds, and while for the write operation it takes a bit less time. So yeah, this is only for when you have 4 threads, but if you have more threads, and it will be more faster. So I think this is the read and write testing for 4 threads, but you can try to use the other scenario where you can actually test it with more threads, and you can play around with the stress command as well. So yeah, I think this pretty much for Cassandra. So I will use this to compare with ScyllaDB as well, and let's move on to how we install ScyllaDB. So right now we will talk about how to set up ScyllaDB, and I have recently created 2 identical nodes for ScyllaDB. The CPU is 4 CPU, and also the RAM is 8 GB of RAM. So let's start with the installation first. So the installation is kind of similar to what we do on Cassandra. So let's just try to install on one node first, and I will do the second node in a speed run. So you need to update the node, and then we add the Scylla source. So the first one is the keyring. So this I got from the documentation of ScyllaDB, and the version we will use 5.4.3 I believe. And let's add the keyring first, and also this GPG from the Scylla, and also the key, and download the Scylla. Okay, now it's added. We need to run another update for any fixes. And then we also need to install Java. And after install, we also update it. This is from the document, so I just follow along what they are told me to do. And yeah, this one is installing Java. Okay, Oops. So once finished installing Java, we just hit sudo update and yeah, and also install Scylla at the last moment. And I'm pretty sure it download 5.4.3. Oh, yep, it is. So the ScyllaDB is version 5.4.3, and this is just this is like the latest version. And yep, after everything installed, ScyllaDB is ready to go. But one thing, the difference is that the ScyllaDB does not run the service automatically like Cassandra after you install it, so we don't need to actually clear its cache. So this is the installation, and let's go on to configuration. So moving on to configuration, we just do a similar to Cassandra, but Scylla has more setup configurations, so let's try. And oh, this is not optional. Okay, so let me show you the default config first. So the config is in etc scylla.yml, so it's similar to Cassandra. So this is the original config for Scylla. It does not come with cluster name, so it's commented out. So if we want to run it, we just uncomment it, and yeah, the data file directory also commented, but it's set as default. And the other is pretty much similar. We have the C provider, listen address, and also broadcast and RPC address is commented. Oh, here RPC address is here, and also broadcast RPC already commented. And yeah, it's pretty much a simpler version of Cassandra. So let me just I have prepared a config, so let's just remove it first and then nano it back to add my configuration. So in here I have set the cluster name to Cambodia like I said for Cassandra, but we can also try other name. But yeah, let's try Cambodia first. And this listen address is the private IP. Let me check the private IP of Scylla real quick. This is 1, so it's 3. Let me put to 3. But I will be joining the second cluster as well, I think. Let me check its IP. Oh, it's 2, so it's really the same thing. Okay, so this one is 3, and RPC address, and also the broadcast IPv4. Let's grab real quick and paste. Okay, so this is I think it's a simpler version. Oh, I forgot to mention, we need to add this developer mode equals true for optimizing the performance for the development server. We don't want it to like production yet, because yeah, we are in developing mode. So let's add that for optimization, and yeah, let's paste it into the configuration, save and exit. And then the next thing you want to do after set the configuration, you need to run sudo Scylla setup. So this is important. If you don't run it, it will not work. So let's run it. You will be prompt a bunch of stuff. Let me zoom out a little bit. Okay, let's run sudo Scylla setup. So first we can skip some of this, but so do you want to run check on your current version? Yes, I would prefer that. And to verify package, yes. And automatically start the Scylla server after the node boot, yes, for sure. And check for a newer version, no, we don't need to. And enable times, yes, we need the time. Also, if you want to set up the disk to format for the RAID, it's also possible. So, but in this case, we don't need to go into this detail. And we say no. And enable core dumps, yes, to prevent the crashes. And then it's start downloading stuff service, and it also prompt us another one. So do you want to set up system wide customize config? No, we don't need a system wide. And this IO tool study or this, and yes, we need to set up this. This is important for our Scylla to work. And then we test let the Scylla test the bandwidth. So let's just put a random number, which is 168, cause why not? And this is pretty much will take a while in order to test. So actually, I think we don't really need to put this. We just let it run for some stuff. And yeah, for now, CPU scaling we need to let the node use it. This computer doesn't support CPU scaling. Yes. And we want to lock all memory to Scylla. So this is the server. Actually, the node is for Scylla. You want to configure swap file? Yes. Yes. Auto. Yep. We need automatically set. We don't want to go detail for that. Okay, so now do you want to configure system log to send log to remote repository? Not really, we just say no. So when we do this, it's already done, and yep, we are ready to go. So the next step is to enable the service. We hit enable, and then we start the service as well, and it will take some time to start, and we can check its status. So it failed to start, I think because we set the config. So we don't need the config to actually set to 2 nodes yet. We just need 1 node, because if we start with 2 nodes, it might cause a problem. Let's delete it and restart the service. So it actually take a while to restart, so it's better not put 2 seeds first. So let's check the when we put 1 node, it actually working. And let's check the status of the node 2. So yeah, we only need to start 1 node at a time. Put the seed to the first node since we are already running only 1. So the first node we can just put 1 seed, and the second node we actually can put the 2 seeds. So right now it's actually working now. The node 2 status is working. Let me try to join the cluster from the node 1. Let's try SQL first to see what's going on. Okay, so it's connected to Cambodia. Okay, so that's pretty good. So right now I will do for Scylla node 2 to see if it joins the cluster. So I'll be back. So right now I just finished installing the Scylla on the node 2. Let's run node 2 status to check if it's actually joined the cluster. Wow, okay, so there's 2 nodes now, so which means it's already in the cluster. So let's do SQL. There we go, it's connected to Cambodia, and let me try to insert something on one. So let's try to create a Keyspace. So we will be using replication factor tool like we do in Cassandra. It's the same thing actually. And create table, but this time we call it university table. Let's use no, actually let's create it, and then another table is a bank. Okay, so let's check if the data is inserted, and we need to insert it first. Insert all of them, insert all of these as well for the bank, and let's select all to see if it's this one is university, it's in. Okay, so let's do it for node 2. We need to use the Cambodia Keyspace first, and then paste in the select all from university. There you go, it's there now. on bank. Okay, so it's actually working for both. So this is pretty much for the configuration installation, and let me talk about the backup and restore. For backup and restore, it's pretty much the same thing as we did in Cassandra. So let me exit this and clear, and for this as well, exit and clear. Exit first and then clear. Okay, so what we need to do is we need to flush before create a snapshot, but actually it will automatically flush if you just run the no-tool snapshot. So let's call it ABC as before, and yep, it's already created the snapshot, and the directory will be in this. Let me cd into that, and then list cd Cambodia list. Yep, there's it. Bank and university. For bank, yep, we can see the files, but the file format is actually different than the Cassandra, but it's okay. It's still stored as a SS table, and binary is the same thing, but it has staging and upload directory. I'm not sure what it is for, but so in order to restore, we just override these, and yep, so this is how to make the snapshot. And the second one as well, let's cd into the data path. Okay, so and let's move on to the restore, and in this case we need to actually clear the file, actually the data first. So let's try to delete everything. So use Cambodia and truncate university, and also truncate the, I forgot, a bank. Yep, bank, and oh, I double. Okay, so let's select from the bank if there actually any file. Okay, no data. Bank as well. So this is pretty good, and let's clear, and now let's restore. So for the restore, let's stop the service for Cassandra. I mean Scylla. I'm a little confused here. Let's stop on the node 2 as well, since we are going to restore the data, and it's gonna take a while for it to stop actually. So we just wait, and then we go into the directory of the table. So in this case, we will restore the bank table. We don't try to restore the university yet. So let's try to actually restore the bank table only. So right now I will just wait for the service to stop. So it's gonna take a bit to stop. So right now the node has already stopped, and let's go into the bank. Oh, we're already in the bank, and let's list it again. So it actually deleting all the stuff, and it says pending delete. So it is the reason why we it takes some time to stop. And yeah, let's cd into the snapshot first. I think let's just run it from here. Let's snapshot, and I think it's pretty much ABC. Yep, and the bank. No. Okay, let's list. Oh, actually it's actually different. Oh no, it's the same. Okay, so we're already in the table bank here, and let's copy all this stuff and put it into the main directory of the table. So we run this cp snapshot abc start and to the same place, and boom, we're done. And let's list. So it's actually there right now. You can see the file here, and yep, this is done for the bank. And let's move on to the second node as well, and we're gonna go into the Cambodia Keyspace, and then go to bank table, and then yep, and then we copy all the same directory into the snapshot. and yep, and then we do a list, and there we go, it's all the file here. And then once everything is done, make sure we start the server. And let's start the server. Let's start for this as well. So earlier I tried to start the service after the backup, but it failed, and I actually go and read the doc again. We actually need to allow the permission first before we actually start the service. So therefore we need to allow the permission to the table that we just back up, and to Scylla, and then use the table name also for the backup table. And after we allow the backup, we can just start the service very quickly. Let me start it again, and it should be done very quick. So there you go, it's already starting up now. And earlier I tried to do for to fix the problem for the Scylla 2, so I already started for that node. And let's check the service, and yep, it's running now. And check for the one as well, and it's running now. So let's run node 2 status. And okay, there you go, it's up now for both, and we don't need to check into this one. So let's just go into CSQL SH I meant, and then use the Cambodia Keyspace. And I believe, oh, I forgot to do one thing, is once it's up running, we need to repair it first. So let's just run a quick repair, and it will repair eventually after any backup. So yeah, this is a must. So you need to repair first, and then we can check to see the data file. So now it's finished, and let's select all from the university. So I'm pretty sure there's no data. Okay, so now let's use the bank, and there we go, it's all coming back right now. So let's try for this as well. CQLSH, use Cambodia, select all from bank, and there we go. So this is the backup process. And yeah, it is a bit different from ScyllaDB, I mean from Cassandra, and we need to allow the permission, but we can actually allow the permission for the entire key space again if you have dealing with multiple tables. And yeah, for I'm pretty sure to make this working for Cassandra over here, I think you should actually enable the permission as well for the after you back up from the snapshot. And let me include it just in case any problem happening. Oh, let me copy this one and then paste it over here for on document. And this one is Cassandra, and the location is Cassandra, not Scylla. And yep, it's pretty much very similar. We just add the permission for it. And now yeah, that's pretty much it for the backup and restore process. And now let's move on to the read and write test. So right now let's do the stress test on the Scylla nodes, and we will use the Cassandra stress tool, but I created another droplet just similar to Cassandra stress that we tested earlier. The thing is it requires to install ScyllaDB in order to run the command. If we use the Cassandra stress when we install Cassandra, it would not work because it's not compatible with each other. So I have to like create another server and install the ScyllaDB on the server, and then we run tests from that server. But still the command use the Cassandra test. So I have prepared this. We will use the same commands as before, and let's test the writing speed first. And yeah, let's try and see what happens. So for this ScyllaDB, I run tests on writing 1 million record. It's somehow the speed is really similar to Cassandra, but it's a bit different. And yeah, it's finished in 1 minute and 33 seconds. And let's try for the read. So in the read, we're gonna read 1 million record as well, and let's find out. So from the read operation, we can see that it actually reads better than write, and it only reads a finish in 1 minute and 18 seconds. So I believe they are somehow a similar speed to Cassandra on write, but the read is much better. And we can see that this is just a 4 CPU, but in reality when we do production, we will actually use the more specification for the server, and for 1 million records and with only 4 threads, and this minimum difference can actually make big difference when we scale it up. So yeah, this have shown that the read speed of Scylla is very much faster for a million record. And yep, and you can see all the stats. Yeah, this is pretty much for the read and write test. So yeah, in conclusion, I think both Cassandra and ScyllaDB are the best NoSQL database out there right now, and it's pretty much kind of similar, just one has a bit faster. And yeah, you can use pretty much any of those. I believe it will benefit you depending on how you want to use it for your production, and it might have some other requirement when you do it for production. Both of them are right now are open source, but if you use it to a certain limit, it will require you for more information when using it. So please refer to document. And yeah, I think this, I hope I can tell you and guide you through how to set up the two of them. So thank you very much, and see you.